Hello class, for today's lesson is about finding square roots and cube roots of perfect squares and cubes. And here are the learning targets. I can determine the square roots of perfect squares using number patterns and visual models. 2. I can determine the cube roots of perfect cubes using number patterns and concrete representations. Let's have some key terms and definitions, starting with a perfect square. Now, a perfect square is the product of an integer multiplied by itself. Now, we can have a list of numbers here, starting with 1. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. We're just gonna end with 10 because it's your task to find the result starting at 11 and above. And since we're talking about the product of an integer, and we know for a certain that an integer involves both positive and negative, that's why if we are to multiply or add negative sign here, -1 times -1 is +1, and the result would still be the same. So, okay, up until the negative. So, again, -10 times -10 is +100. And by the way, the ones that I have written here are expanded forms. So, whether we use the positive or the negative numbers, so it is written as this. So 1 squared or -1 squared. Again, as long as the number and the sign are inside the parentheses. Okay, so 2 squared until, let's have what we're given here, until 10 squared or -10 squared. Again, we already discussed this during the JAMDAS last quarter, so I hope you still remember that. Okay, so yeah, that's it. Now, we have here the next key term. So we have the square root, which means a number that is the product of an integer multiplied by itself. And this here is our square root sign or radical sign. Now here, as you can see, actually you're not seeing anything, but there is an invisible 2 which signifies the square or for square root. So yeah, let me just erase this one. Now, based on the definition, so for example, we have the square root of 1. We know for a certain that 1 is a perfect square. So basically, the answer for this is positive and -1. Another thing, if we have 4, the square root of 4 or the square roots of 4 are positive and -2. If we have for 9, we also have positive and -3. And the list goes on. Now, Again, just remember that in square root and what do you call this? The perfect square, it's just undoing the other. Now, what if you are given this? The square root of, let's just say, 12. For now, at your level in grade 7, the answer for this would be positive and negative square root of 12. When you reach grade 9, this will be broken down into a simpler number. But for the meantime, just use or have this kind of answer. Again, you only do this if the number inside the square root or the radical sign is not a perfect square. And I hope that's clear. This time, let us try to get the point on how to represent this and how to represent perfect square or the square root. Now, from the word square, so just bear with me as I draw. I'm not good with that, but I'm gonna do my best. So you have it here. I'm not sure if this is a perfect square. However, yeah, I'll just assume. Now, if you are going to, if we're going to have a perfect square of 1, then that means each side here is 1. And obviously, this here is 1 square. Let's try another one. Let's have 2. 2 squared is 4. So let's draw another square here. Again, just bear with me, just assume that everything is in square. So we have here, this is 2 units and 2 units. So that means if you get to have 2 units, 2 times 2, so we get to have 4 square. So we have here 1 square unit, 1 square unit, 1 square unit, 1 square unit. And if you add them, we get to have 4 square units. 4 square units. Now let's try 3. So 3 squared. Again, we know that 3 squared is 9. So if we are to represent this using a square, obviously. So, oops. I'm not sure. Oops. Okay. I hope I could do this right. Oops. Again, this is not a perfect square because I'm not good with drawing, but just bear with me. Now here, if we have 3 units, whether this is a centimeter or what do you call this, or any metric system or measurement being used, so we have here 3 units. Okay, so we know that 3 times 3 is 9, so each of these square here will have 1 square unit. And if you add all of them, we get to have 9 square units inside. Okay, so 9 square units. Square. And by the way, when we talk about a perfect square or a perfect square or square roots, this is just a 2D. It's like describing any shape or figure that has only length and width but no thickness. So 2D from the word two-dimensional. So everything is flat as you can see here, and only again two measurements, length and width. And this examples for this would be square, rectangle, triangle, circle, hexagon, and other flat objects. To add, here we have the length, okay, of the bottom and top area, and here on the side we have the width. Okay, and that's it only for 2D in relation to what do you call this? Perfect square and square root. So just a recap of this, everything that is inside, okay, let's just have this as 9 square units. If we're gonna take out or undo the 9 square units, obviously we have 3 units here and 3 units here. So that also means, since this is literally a perfect square, that means, let me erase it. That also means if the one here on top is 3 units, that means this one here is also 3 units because this is a square, obviously. And don't forget that when we are talking about the space inside of a 2D object, its label should always be in square units. Again, it depends on the measurement. It could be meters, kilometers, or whatever. As long as if you're not given a certain metric or measurement, just write square units. But if we're only talking about the length or the width, just write units. And I hope that's clear. Okay, let me just write. If only for length or width, okay, so just units, or it depends on the given. It could be cm, whatever that is given. If we're talking about the area or the space inside, okay, it should be in square units. Okay, again, it also depends. It could be like this, okay, etc. Now let's have the perfect cube. A perfect cube is a number that is the product of an integer multiplied by itself 3 times. Now I'm just gonna write 3 perfect cubes. So if we are to write, we have 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. So as we expand this would be 1 times 1 times 1, which is equal to 1. Next would be 2 times 2 times 2, which is equal to 8. This one would be 3 times 3 times 3, which is equal to 27. This we have 4 times 4 times 4, which is 64. And last example is 5 times 5 times 5 is equal to 125. So I'm just gonna end at 5, and it is your task or responsibility to find the next numbers or result or the pattern of the perfect cubes. Just a thing, you may have a table of values for you to memorize or familiarize with the perfect square and perfect cubes. It's up to you if you're gonna go until 15 or 20 or even higher than that. Anyway, as you can see here, all of them are positive. That is why we get to have positive results. We have the 1, 8, 27, 64, and 125. However, if we are going to have negative numbers in perfect cubes. Okay, based on this, we have here, if we're going to expand -1 times -1 times -1. If we're going to follow the signs, you have here, negative times negative is positive, positive times negative is negative, and you multiply the base numbers, the base number, which is 1. So 1 times 1 times 1 is 1. So the result is -1. So same goes with other numbers as we expand them. So -2 times -2, we have -8, -3, -3, which is -27, -4, -4, -4, which is -64. And last we have -5, -5, -5, which is -125. Now here is a code for this. If your base here, for example this one, if your base is positive, any exponent, any positive exponent would also result to a positive result. However, as you can see here, the base is negative. So if the exponent is an odd number, the result will be negative as well. If you could recall, if you have, for example, you have the -1 squared. Based on this, right, if we expand this, we have -1 times -1. Obviously, negative times negative is positive, and 1 times 1 is 1. So if your base is negative, and if your exponent is an even number, the result would be positive. However, if your base is negative and your exponent is odd, the result would be negative. Now let's have our last key term in definition, which is the cube root. This is a number that, when multiplied by itself 3 times, gives the original number. For example, by the way, this is the symbol for a cube root. Okay, so this time it has a visible number, which is 3, unlike with square root. Now, if we have here an example, a perfect cube, which is 1. So if we are to break this down, this is 1 times 1 times 1. So obviously, since we have broken this down into 1, 1, 1, then that means the answer is 1. Another thing, same thing with 8. So if we break this down, we have 2 times 2 times 2. That means the answer is 2. And let's have our last example. We have the cube root of 125. So break this down, we have 5 times 5 times 5, which is 5. So whether it's a perfect square, whether it's square root or cube root, we just need to make sure that, for example, if we are dealing with cube root, then there should be 3 numbers that are the same inside the radical sign. Although I have not written this earlier with square root, so just to add, so we have the square root of 4. If we break this down, so we have 2 and 2, and obviously the 2 numbers are the same. That means the answer is 2. Or it could also be -2 and -2. That means we have 2 answers. Same with earlier. Now let's have the last part, in which is about the representation, or representing a perfect cube. So earlier, when we had the perfect square, it is in 2D, but this time it is in 3D, which means 3-dimensional. This time, we now have the length, the width, and height. In a 2D, height is absent. You only have length and width for 2D, but this time for 3D, we now have this one. So if we are to draw one squared, I mean one cubed, okay, so one cube, which is 1. This only means that we have here. I'm not really good with this, so wait, let me just change color. So bear with me. Oops. Okay, so we have here for our length. This is our length here. Length. This is our width. And this is our height. So based on this, we're gonna talk about cube or cubic units. So this is in volume. So this is the space inside a 3D object. But based on this, is this just in cube? So here we have 1 unit. Because this, just say this is here. Let's assume this is 1 unit. Same goes with other stuff. With the other side, I mean, 1 unit. And the list goes on. We just know that every measurement in a cube is 1 unit. So if you are to find the unit or the volume of a cube, so we have here, right, 1 cube is 1. That means this is 1 cubic unit. Now, if you're also to have 2 cubed, so still the same illustration, however, okay, so we have the length, the width, the height. So if we are going to have 2 units, 2 units. And same thing with everything. So let us try to divide this to 2. It would look like this. Yeah. So again, we know that 2 cubed is 8. That means if we're going to have write this, we have 8 cubic units. Again, if we're talking about cubic units, this is under volume. And volume is the space inside of a 3D object. So if you are given a certain measurement, if it could be in centimeter, meter, or whatever measurement that is given, let's assume this is in centimeters. So we write this as 8 cubic centimeters per se. And that's it for today's lesson.